Assalamu alaikum guys, welcome back. This is Shafat Khan on your screen. Okay guys, so we are back with the AS chemistry crash course, and this is our lecture 11, and in this lecture we're gonna do a new topic, that is moles. Okay, in this video I'm specifically gonna revise all the formulas that are used in this chapter, moles. Okay, and we are not gonna do quite a lot of calculations over here because that calculative portion is going to be covered mainly in your past paper practice if you have any. Okay, when you do past papers, so I would really recommend do the moles portion from there. Okay, so now let's get started. Okay, so first of all we need to define what moles are. There is actually nothing new in moles. Moles is the same concept as the one which you guys did in your O levels. Okay, now moles by definition, it is an amount of substance. Okay, it is the amount of a substance. And what type of a substance? Basically it is that much amount of a substance which contains equal number of particles as the number of particles which are present in 12 grams of carbon 12 grams of carbon 12. Okay, this is a standard that we have used for the moles scale. Okay, so basically in order to calculate 1 mole we need to take an amount which contains a certain number of particles, and that number of particles must be equal to the number of particles present in this standard that we have set. Okay, this is a definition of mole. So if you are asked on your exams to define moles, so this is what you are supposed to write for at least 2 marks. Okay, so what are moles? Moles is an amount of a substance. Okay, by the way, it's a physical quantity. Okay, it's a quantity, physical quantity, just like length, time, speed, etc. Moles is also a physical quantity, and it's a fundamental physical quantity. You guys must have learned about that in your O-level physics. It is the amount of a substance which contains the same number of particles as which are present in 12 grams of carbon 12. The amount of a substance, the number of particles which are present in a certain amount, they must be equal to the number of particles which are present in 12 grams of carbon 12. Okay, so if I take a sample of carbon 12, okay, 12 grams basically, and if I, for example, somehow I count all the number of particles in there, that those number of, basically the atoms are the particles of carbon 12. So those particles, that number which I would get, that number must be present in any other amount of a substance. Okay, any other substance, for example I have oxygen. Okay, the number of atoms in oxygen must be the same as those present in carbon. So in that case, in that particular amount which contains the same particles as present in carbon 12 would be the mole of oxygen. Okay, in short, this number of particles which are present in 12 grams of carbon 12, it has already been calculated by a scientist known as Avogadro, and therefore this number is called the Avogadro's constant. Okay, symbolized by L. It has a fixed value 6.02 raised to the power of 23, and I know most of you might have learned this value. These are the number of carbon 12 atoms present in 12 grams of carbon 12. Okay, and these are the number of particles that must be present in any other substance in order to call that much amount in any amount of a substance, in order to call that much amount 1 mole. Okay, so mole by definition is simply an amount of a particular substance which contains this many atoms. So in other words, you can define the moles as being the amount of a substance that contains the Avogadro's number of particles. That's it. That's also the right definition of moles. Okay, this was the definition, and this is important because it has been asked on the past paper several times. This constant is very important, and I would suggest you guys should learn this constant, although it is given in the data booklet as well. Now coming to the formulas which are used in moles. How can you calculate the mole? This was the definition, the verbal definition, but let's write it mathematically. So moles are equal to the number of mass, to the given mass in grams. Okay, the mass which is given to you in grams of a substance divided by the molar mass of that substance. Okay, for example, I've got, let's say, 10 grams of oxygen, or 10 grams of, let's say, sodium, for instance, 10 grams of sodium, and if I were to ask you to give me the moles of sodium which are present in 10 grams of sodium, so how are you going to do that? Well, it's simple. you're gonna just put it into this formula. So the given mass in grams of sodium in this case is 10 and the molar mass of sodium is 23 from the periodic table, meaning the relative atomic mass of sodium is 23. So 10 upon 23 and you'll get your answer. Okay, I'm not doing it further. So those are the number of moles which are present in case of sodium, in this much amount of sodium. Then, for example, if you have a compound, let's say C6H12O6 glucose, and let's say you've got 360 grams of glucose, and if I were to ask you to give me the amount of moles present in this glucose, in 360 grams of glucose, just again use the same formula. Moles is equal to mass upon molar mass. So the given mass is 360. Molar mass is, for glucose, I think it's around 180. So it's gonna give us an answer of 2. Simple. Okay, so I'm not doing any other example on this formula. You guys have already done this formula in detail in your O levels as well. Then coming to the second formula, moles is equal to number of particles divided by the Avogadro's constant. Okay, now these particles can be atoms, they can be ions, they can be molecules, they can be electrons, they can be anything. Okay, any particle which is present in an element can be the number of particles present over here. Okay, for example, I've got, let's say 3.01 raised to the power of 23 atoms of oxygen. If I were to ask you to give me the amount of moles present in this sample of oxygen, the amount of moles of atoms, oxygen atoms, then what's going to be the solution? It's simple, just plug it into this formula. We're going to take this 3.01, place it in the numerator and divide it by this number, and you are going to get an answer of 1 upon 2. Right, because this is exactly half of 36.02 raised to the power of 23. I'm not doing another example on this because this is also an easy formula and you've been doing it since your O levels. You can merge these formulas as well. Okay, as you guys know that given mass upon molar mass, since it is equal to moles, and the number of particles divided by this number is also equal to moles, so this fraction is also equal to this fraction. Okay, so if you equate the two fractions, then of course you can calculate anything the examiner has asked you in the questions, and I'm not doing that over here as well. Now, because this is a complete revision from your O levels, okay, nothing new. Now for gases, this is also from O levels, but guys, now over here this gases part is very important because there are tons of questions concerning the gases. Okay, now let's look at these. For gases, 1 mole of any gas, it will always occupy a volume of 24 dm cube at room temperature and pressure. Okay, at room temperature and pressure, this is the volume that must be occupied by 1 mole of a gas, and at standard temperature and pressure, this is the volume that must be occupied by 1 mole of a gas. Okay, these are two slightly different volumes, but you must know both the volumes. Okay, and standard temperature and pressure is different from room temperature and pressure. Okay, you must be knowing that already. Room temperature and pressure is 25 degrees Celsius and 1 atmosphere, whereas standard temperature and pressure is around 0 degrees Celsius. Okay, look at the change in the temperature, 25 and 0. Apart from that, the room temperature and pressure, this one RTP, are also known as standard conditions. Okay, standard conditions, not standard temperature and pressure. They are called standard conditions. This can be a bit confusing for some of the students. Sometimes it's given to you to it is asked to calculate the moles under standard conditions. So under standard conditions it's going to be under RTP, but at standard temperature and pressure is going to be STP. Okay, these are the two different things. Standard conditions imply to RTP, but standard temperature and pressure apply to STP. Okay, and then finally the concentration. How are you going to calculate the concentration of a solution? Basically, concentration of a solution. So in case of a solution, you can calculate it either in moles per dm cube or in grams per dm cube. Okay, as the formula suggests, mole per dm cube. Mole per dm cube means moles are in the numerator, and per dm cube means the dm cube is in the denominator. So the amount of moles is gonna be in the numerator, and the volume in dm cube is gonna be in the denominator. Now if this volume instead of dm cube is taken in cm cube, then you'll get a different unit, you'll get an answer in mole per cm cube. Okay, and I'm assuming you guys know that. Then in grams per dm cube, how to calculate the concentration in grams per dm cube? In this case, you are not going to use the moles, but rather you are going to use the grams divided by dm cube. Okay, and by the way, these two formulas can also be linked with one another using the first formula of moles. Okay, so now how to do that? That formula was moles is equal to the given mass in grams, given mass divided by molar mass, right? mR. Over here, you can also write this formula, meaning both the formulas, in that form. Okay, concentration given in mole per dm cube is actually equal to the concentration given in grams per dm cube divided by mR of that particular substance. So you can use this conversion formula interconvert between the two concentrations of a particular substance, of the same substance. Okay, not of two different substances, of course. So if for example you've been given 2 moles per dm cube solution of glucose and how to convert that into grams per dm cube, you could just use this formula. Plug in the 2 over here, the mR of glucose is 180 and grams per dm cube is in the numerator. You just multiply both the sides by 180 and you'll get your answer in grams per dm cube. Clear? So this pretty much sums up the formulas which are used in moles, the basic formulas from your O levels. Apart from these formulas, you also have the formulas for percentage yield and percentage purity, and we'll be doing that maybe in the next lecture or maybe with the past papers, if we do any past papers. Okay, percentage yield and percentage purity, and apart from that, percentage yield, percentage purity, empirical formula and molecular formula calculations. How to calculate your empirical formula and how to calculate your molecular formula. This was the complete syllabus of this chapter and nothing else is added to it. Okay, so there is nothing new in here in this chapter. Entirely the syllabus of O levels applies over here. Okay, so that's it for this video. Thank you.